There are different types of reciprocal internal combustion engines. One first way of categorizing these different engines is to count the number of strokes that are necessary for the thermodynamic cycle that we have in the engine. A stroke corresponds to movements of the piston inside the cylinder, either from the bottom dead center to the top dead center, or from the top dead center to the bottom dead center. So if we have one full rotation on the engine axis, it means that we have two strokes involved. There are mainly two types of reciprocal internal combustion engines. In terms of strokes, we can find two-stroke and four-stroke engines. In this chapter, we will only deal with four-stroke engines because it's the main type of engine we can find, for example, in cars. Then, among the four-stroke engines, we can also find two main types of engines. So we usually call them on cars gasoline engine and diesel engine, but here we will use more appropriate names that don't only refer to the fuel that is used. So the gasoline engine is called here the spark ignition engine, because gasoline mostly refers to the main fuel that is used for this engine, but it can be used also for other fuels. So spark ignition engine, we'll see when describing the cycle what it means exactly. So let's present the different steps we have during this cycle. So it's a cycle, so the things are repeating after each other. We need to start somewhere, so I suggest we start from the beginning of the admission stroke. As we have said before, we have four strokes that will take place after each other. So we can find these four strokes, and also something that is taking place almost instantaneously between two strokes. So let's start with the first stroke that we can call the admission stroke. For this stroke, it starts at the top dead center. The volume is the minimum volume. We have the clearance volume inside the cylinder, and it contains smoke from the previous cycle that is at low pressure. At the beginning of this stroke, the admission valves are open, and the piston is going down from the top dead center to the bottom dead center during this admission stroke. Due to the increase of volume inside the cylinder, this tends to cause volumetric expansion, and so a decrease of pressure inside the cylinder. So this way, this decrease of pressure will cause the admission of the fuel that is present in the admission line, and of the gas that is present inside the admission line. And in the case of the spark ignition engine, this gas is already a mixture of air, the combustive, and of fuel, so quite often vapors of gasoline. So that's one of the key items of the spark ignition engines. The admission is done with a mixture of fuel and combustive. So the piston is going down. We fill the volume inside the cylinder with this mixture of air and fuel, and because we have a sinusoidal movement of the piston, then the velocity of the piston is decreasing when the piston is reaching the bottom dead center, and the pressure is equilibrating between the inside of the cylinder and the admission line, and we usually have the same pressure than the admission line at the end of the admission stroke. At this moment, the admission valves are closing, and this is the end of the first stroke. Because the admission valves are closed, now things are working in a closed system. The second step will be the compression of the air-fuel mixture. So now the piston is going up from the bottom dead center to the top dead center. This is what we call a volumetric compression. So the same name, compression, can be used either to mean a decrease in volume or an increase in pressure, but depending on the heat transfer, both increase of pressure and decrease of volume may be two different things. In this case, what is done is a decrease of the volume, and this tends to increase pressure and temperature. In a real motor, this compression is not adiabatic because there are non-negligible heat transfer with the side walls of the motor, because the motor body is cooled down by the cooling liquids of the engine. So the pressure and the temperature is increasing during the compression. There's one thing we don't want to take place here, is an autonomous ignition and combustion of the fluid, because we want to control when the ignition is starting, and we want it to start only once the piston is at the top dead center. If ignition starts too early while the piston is going up, then it will cause a sudden increase in pressure inside the cylinder, and that will push the piston the wrong way, and it will destroy quite fast the engine. So that's something we want to avoid. In order to avoid that, we need to avoid the mixture to reach what we call the auto-ignition temperature. So it means that the condition at which combustion starts mostly depends on temperature and not on pressure. So we don't want to increase too much the temperature and to increase it over the auto-ignition temperature during the compression. For this, we have two strategies. First, we choose a fuel with a high auto-ignition temperature. That's one of the differences between gasoline and oil or diesel fuel. Second thing we do for this strategy, we don't compress too much. So what we call the volumetric compression ratio, so that's the ratio between the maximum volume we have at the bottom dead center by the clearance volume. So this volumetric compression ratio in this kind of engine is around 6 to 8 or 9, in order not to compress too much and not to increase too much the temperature at the end of the compression. So at the end of the compression stroke, then we have all the mixture, air and fuel, concentrated inside the clearance volume, and that's when we want to start combustion. In order to do this, we use the spark plug that is present at the top part of the engine inside the clearance volume. The spark plug will create a spark that will locally increase the temperature above the auto-ignition temperature. So combustion will take place locally, and this combustion of the fuel will release a lot of heat that will heat up the fluid all around. And because here the fuel is already premixed with the air. So from a chemical point of view, the fuel molecula are always close to dioxygen molecula. Then there is a very fast development of combustion, and combustion of the whole fuel will take place very fast. So that's one of the particularity of this type of engine. Combustion is very fast. Combustion will release a lot of heat, and this heat that will tend to increase suddenly the pressure and the temperature inside the clearance volume. We now have the third stroke that will take place. The pistons will go down from the top dead center to the bottom dead center. This is a volumetric expansion, and during this expansion the fluid will give some work to the piston. We can note here that it's the only useful stroke of the engine, because that's the only stroke for which the fluid is giving work to the piston, while during all the other strokes the piston is giving work to the fluid, especially for the compression stroke. But due to the fact that the fluid is giving more work to the piston during this expansion stroke than the sum of all the work given by the piston to the fluid, it's still an engine, because we have on average work that is given from the fluid to the piston. So during the expansion stroke, the piston is going down to the bottom dead center, but at the bottom dead center the pressure inside the cylinder is still higher than the atmospheric pressure that we have in the exhaust line. At this moment, at the bottom dead center, or usually a little bit before, the exhaust valves are opening. And due to the big difference of pressure between inside the cylinder and in the exhaust line, most of the smoke is pushed very fast outside of the cylinder to the exhaust line. This is creating a pressure wave in the exhaust line, and that's the reason for most of the noise that is emitted by this kind of engine. We then have the fourth stroke, for which the piston is going up, so it's creating a slight volumetric compression, and so it's increasing a little bit the pressure inside the cylinder. That will cause most of the smoke to go out to the exhaust line. When the piston reaches the top dead center, then we still have the clearance volume full of smoke, and at this moment the exhaust valves will close and the admission valves will open, and it's starting a new cycle for the spark ignition engine. So, as it has been described, we need 4 different strokes to do a full cycle. So we need 2 full rotations on the crankshaft in order to perform 1 cycle on this kind of engine.